So what we've gone through there previously was the idea of what that looks like with numbers, and I think doing it in numbers helps you to visualise it. Now what I'm going to do here in terms of your class notes is simply do it with the idea of like price, quantity, for you to see where those relationships occur. So if you imagine, we've still got this idea of total revenue and marginal revenue as part of that process. I'll draw an axis here. So quantity, price, and then what we're going to do is marry that up with another diagram, quantity, and this component again being some kind of physical value. I don't think I'd call it price as such, but it will be in pounds. So there are a couple of mathematical relationships. So at the moment, you should be aware that we have a marginal revenue curve, which at some point will cut and intersect the x-axis. Okay, and we have an average revenue curve that separates itself from it. Average revenue which equals demand. And we're going to bring these two together. So, going back to what you told me earlier, we said that at this point here, when the marginal revenue intersects, that's where revenue is going to be what? Maximised, at its highest. So if you imagine, if this is a total revenue curve, okay, there will also become a point, obviously, when I set a particular price. So if you imagine, where have I got that idea? So, okay, so imagine that's my total revenue curve. I'm not going to worry too much that they don't marry up. It's the principles that are more important than the kind of technicalities of it. So, what this tells us, at this particular point, so within here, we can see that based upon this information, the reduction in price is leading to an increase in total revenue. So as I move along this curve, so I'm moving down here and increasing the quantity, I am also moving up this point here. Okay, I could represent that with drawing some cues, but I don't want to overcomplicate it. So within those areas, what that means is, if I'm lowering price but increasing total revenue, we have argued that the PED of those products are what? Elastic. And when we did that in year 12, we would have drawn price, quantity, a very superficial looking curve that says, look at this, everything's elastic on it, and if I lower that price, P to P2, Q to Q2, this black box is described as what?
Revenue gains.
So I'm lowering the price, increasing the quantity, so that is revenue lost. This blue box is revenue gained. The blue box, so the blue revenue is greater than the black revenue, which means an increase in revenue overall. As represented here, as I'm increasing quantity, total revenue is going up. Q2, total revenue, 2, increase quantity to Q3, total revenue is going up. If I increase to Q4, total revenue is going up. Q5, total revenue is going up, etc., etc. So, in terms of what we've got here, so this particular area, which is of interest for us as an economist, when marginal revenue equals 0, which is a formula, we know that we have hit the point of revenue maximisation. Revenue max. Okay, and again, this is illustrated in that curve. Here is TR max. And the reason it is at the point 0 is that all of that revenue, all of the marginal revenue of previous units is accumulated. So the logic is that all of the previous MR gained at earlier quantities is accumulated. It's not lost. But beyond MR equals 0, so i.e. beyond Q, MR is a negative number. How could it be a negative number? So if we go back to this idea of elasticity, in this area of my diagram, I'm still lowering price, but total revenue is falling, which means that this part of the diagram must therefore be described as PED inelastic. So in year 12, we would have drawn a kind of quite superficial looking inelastic curve, price, quantity, P, P2, Q, Q2, demand. Here, this top box is revenue lost. Below that is revenue gained. And in that diagram, we can see that the revenue gained is less than the revenue that is lost, which means a reduction in revenue overall. Hence why, as you continue to increase output, so if I look at the idea here, so if you imagine, let's call that Q6, so Q3 and Q6 quantity, they both provide the same total revenue. So here is Q rev max, where MR equals 0. Q rev max. Okay, $1 million question then. If that bit is elastic, that bit is inelastic, at some point here we would have been unitary, i.e. equal to what number? 1. Or minus 1 if you're going to be kind of overly technical about it. Okay. So the logic there, obviously in year 12 we did these slopes that were to overemphasise the nature of what it meant to be elastic and inelastic, but in reality demand curves do not look like that. Okay? If you can imagine the idea of reality, at very high price levels, very few people are going to be able to afford something. At lower price levels, more people will afford something, but you'll hit a certain point where you just don't want to consume anymore. So actually, demand curves in general will look something like that. Okay? And what that means is that PED will change along the curve at different prices. Okay? There'll be a point at the start where it's elastic. It will then get to a point where it becomes inelastic, and there will be an area. It might not be a single point, it could be an area that is then actually unitary, because that is realistically what a demand curve will look like, not a straight line. Okay? Any questions with that at all? Any questions with it as a topic? As I've mentioned, I appreciate that that looks quite technical, but if you think about what we did first on the graph paper to illustrate it, I'm hoping that the illustration makes sense. And again, if you then just give yourself little examples of it as a product, I've done it obviously here with a foot-long sandwich. You do it with whatever product that you consume with a variety of manners. At what point would you simply stop consuming it, and vice versa? Okay?
Wait, so I don't get how, when Q is at 0, that that's revenue maximisation.
So, that quantity there is the quantity that is referring to the marginal revenue curve. So if you imagine, as I go along, so as I lower the price, the change in total revenue is increasing, and it's increasing by smaller amounts as I move along, but nevertheless it is increasing. So if you go back to the numbers that we used earlier, total revenue was 10, it then became 18, so it went up by 8, it then became 24, so it went up by 6. So each time it's getting smaller. When we hit 0, anything beyond that, the marginal revenue will become negative, so total revenue will fall. When it hits 0, because 0 doesn't add anything to it, I can understand where you might say, well actually then, if it's not adding anything, how can that be the maximum amount? But what you kind of got in that idea is, well, because it's a maximum point in the sense that it's the peak of that curve. So you go all the way right up to that point, even if it's like a kind of like a fake quantity as such, to take, you want to take all of that kind of revenue from it, and that will only happen at that end point. By it being 0 doesn't mean that you're gaining any revenue or losing any revenue, but it means that 100% you must have gained all of the previous revenue available that was making it go up. So if you stopped at, say for example, you looked at the information, you said, right, well, marginal revenue was highest at 10, surely that's maximum revenue. Well no, that was just the point where the increase in revenue was at its highest. When you then increased the quantity to 2, the marginal revenue went up by 8, which is obviously less than 10, but the 10 isn't lost, it's added on top of it. So I'm adding it on top and on top until there's nothing left to add on top of it, which is why it's 0, which is why that's the maximum, because I've taken absolutely everything I possibly can out. So from a diagrammatic level, imagine that this was like 5 and 6, and you said, well, 6 equals 0, so that's not adding anything, so actually I'm going to stop at 5. Well, from a graphical form, you've lost out on this little area, which has a value. So we go right up to the point where they cross, and that's it. Okay? Yeah. You are not, well, you may get a question that says, like a section A small question that says, right, why is revenue max where MR equals 0? Well, it's only going to be like 3 or 4 marks. Draw those 2 diagrams. I would expect that to make up the majority of those marks. And then you've just got the idea. The demand curve varies in elasticity. It starts off being elastic, it becomes unitary to inelastic, so there's a point where lowering the price will actually cause revenue to fall. Think about your year 12 theory, and therefore you want to get to that point where you get it where it's unitary and the revenue occurs at there. That is just a formula, that, and what it does, you use it to illustrate a point. It's very rare that you'll get asked to explain why is it at that point. But I don't want to tell you, well, revenue max is at MR equals 0. Don't worry why that happens, just remember it. That doesn't do you any good and any knowledge with it. Okay, so if it is a bit confusing, fine. go back over it, but equally, the key part is just to remember that more than anything as well.
I thought that curve down there would be the other way around, so I thought it'd start off quite flat and then get steeper, if you know what I mean.
When you say steeper,
Like, I mean, it starts off quite flat and it goes down like that. So I thought elastic was very shallow.
right, so it only looks like that because we've drawn it in that fashion to really demonstrate it. If you actually dissect it, what's happening there is quite a large proportional change in demand compared to the change in price. There will be quite a big shift. If I was to expand this quite large. Here, if you imagine, that change in demand, like the demand curve just simply stops. So if you carry on increasing price, it's not that there wouldn't be any demand, it's that the demand wouldn't be any different to what it was before that price was any higher. So it's getting as it. So that, the reason why that looks bizarre is ultimately because of the nature of how it is done with these assumptions associated to the year 12 methodology.
Right, okay.
Okay? Right.